Thank you all for joining. I'm Lucian Fogoras. I'm your co-founder, and I'd like to welcome to the stage Patrick Miller, the moderator for this session. Thank you, Patrick.
Thank you so much, Lucian. All right, thank you, everybody. Welcome. Thanks for joining us today. We'll start by familiarizing ourselves with the event tool. Take a look around for the chat. Tell us where you're located in the public space. Happy to see where everyone is from, and that's a real good way to kind of get the icebreaker out there for everybody. Looks like there's some folks from Barcelona. I happen to be in Barcelona right now as well. Cheers. Okay. So please post your questions in the Q&A tool, not in the chat. It'll make it much easier for us to get them all together and answer them. That's just easier for us. We can try to pull them out of the chat, but can't guarantee they're going to get answered there. Housekeeping, some things to be aware of. We are taking questions at the conclusion, so please post them in the Q&A tool, as I mentioned. And then the track is going to run 59 minutes, so we'll have you out of here on time. We want to be mindful of everyone's time. And then it wouldn't be possible to run this virtual conference without our sponsors. So thanks to the sponsors, Schneider Electric, Keyfactor, and Adolis. They are the sponsors for the event. We really appreciate them. So with the housekeeping out of the way, I'd like to introduce our topic and our speakers. The topic today is Fortress Factory, the critical importance of cybersecurity in the IIoT era. I'm Patrick Miller. I'm CEO of Ampex Cyber. I'll be your moderator for this session. We are a specialized industrial consulting firm focusing on the intersection of regulatory standards and security. Keep you ahead of your adversaries and your auditors. So let's get to our speakers. We had three on schedule. Megan Sanford is with Schneider. She's still trying to get in. She's having some technical difficulties. If she can get here, we'll immediately jump into some questions for her. But until then, we've got our fantastic other two panelists who can handle this brilliantly. I've worked with them both before, moderated them for several panels. Ellen and Eric. Ellen, could you tell us about yourself, and then Eric?
Yes. Hi, everybody. So my name is Ellen Boehm, and I'm the SVP of IoT strategy at a company called Keyfactor. Keyfactor is a cybersecurity software company. We specialize in public key infrastructure, certificates, and certificate automation, both for enterprise use cases within enterprise IT. And then also, I'm seeing a lot of growth, and this is really my whole world, is how do we apply those platforms and technologies into IoT, so connected vehicles and medical devices, and then also industrial IoT, which is what we're here to talk about today. So I'm glad to be here and looking forward to it.
Great. My name's Eric Byers. I'm the CEO of Adolis Technology. Many of you know me as the inventor of the Tofino firewall, and a few those little boxes out there protecting OT systems all over the world. I'm no longer involved with Tofino, and I'm focused now on particularly supply chain security because of things that happened back in my Tofino days when I was back at Belden, and seeing this emerging trend of attackers, particularly the Dragonfly attacks back in 2014, where I started to realize that the bad guys were going to be using new tactics, and the new tactics were going to be going for the soft underbelly of control systems and IIoT devices. What's inside them? What's the software? And so my focus since 2014 has been really trying to help people understand what software is actually embedded inside industrial controllers or IIoT devices. And what are we going to do about it? What are the risks? And so that's my day-to-day life, is figuring out what's actually going on in those boxes.
Fantastic. Thanks. Glad to have you both here. So let's get the session started. It's a moderated Q&A, so I'm just going to be firing questions off at our panelists, and they're going to be answering. And with that, I'm going to jump right in. Let's get to the first one. What is the most urgent cyber threat to a manufacturer's OT environment? Like, what's the biggest issue right now? And we'll lead off with Eric.
All right. So I honestly believe that it is supply chain attacks. I mean, I had a pretty good life building firewalls, but firewalls don't defend you from a supply chain attack because it's really taking advantage of the trust that we have between users and vendors. So look back at the Dragonfly attacks. The attackers were going after the vendors. replacing legitimate software with Trojanized software and then getting their users to download that software. And the problem with this type of attack is it's really, they're attacking a secondary party or a third party, and then using that to get tremendous return on investment in their attacks. In the case of Dragonfly, good example, they would attack one supplier and within a week or two have penetration into 300 or 400 OT systems. And so as a result of that return on investment, bad guys are, the attackers today are running businesses, they're agencies, they're sophisticated. That return on investment means that's where they're going to put their effort. So we're seeing this all the time, whether it's SolarWinds or the recent issues with the XZ library, very, very sophisticated attacks. And to me, that is why I'm no longer spending my days on firewalls, is because I think this is a bigger problem.
Yeah, I can add to that too, if you don't mind. So completely agree. I think supply chain security is something that is very important. When I think about how OT environments are now becoming more and more connected, whether it's a factory or whether it's maybe some like a distribution facility or a network of stores or facilities that are all distributed, I'm seeing more and more use of connected like cameras or sensors or IoT things that are being used to collect data and to monitor and manage a lot of these systems that are already in place. So when you take something that has not traditionally been connected and then you add this connectivity piece to it, but you're building it into your operation, you're relying on, as an operator, you're relying on the security policies and practices of whomever you choose, the vendor that you choose to buy that device from. So whether it is the code that's running on the device itself, whether it's the underlying hardware inside of it, and then are there ways to secure, are there ways to for my world, it's place a key and an identity to be able to create a secure connection. You're relying a lot as an operator on how that's been established from these vendors and partners that you're bringing into your system. So I think that's the biggest thing, is because it really is, it still is emerging in terms of adoption and maturity within this market. But there's a lot of smart people that are working on sort of best practices and frameworks, and how do we come up with the right way to do this so that it is scalable and can kind of work within the nature of how everything is connected these days.
Okay, so it sounds like supply chain is one of our biggest issues, and I can see that as well. Is there just a follow-up is this going to be regionalized? Because in some areas I'm seeing things like geopolitical issues and some other stuff coming in with certain threat actors. Is there a higher concern for certain verticals in the manufacturing space or even certain regions? We'll start with you, Ellen.
Yeah, so I think that's an interesting question, because we do follow a lot of this because our customers and partners need to comply. And so, yes, I think so. For example, in Europe, there's a Cyber Resilience Act that people are trying to understand and how to comply with. That's more broad. And then within different industries, so I know today we're really speaking about industrial, but I also participate in the smart home industry or the smart energy industry. And there are, I think, people coming together to try to come up with frameworks that help have guidelines around cybersecurity. So yes, I do see that regionally, there are certain regions that are trying to take this on, because there is, from a critical infrastructure perspective, you want to be able to protect what's important to your country. Let's say there's just even basics around water, transportation, or the systems that run your society. But then when it comes to industry and factories, it's, that's, economics. And so how do you make sure that all of that continues to operate to support your economy? So long way of saying, yes, I think there's no one silver bullet answer, but I do see these emerging by industry verticals and different companies who are competitors coming together to see how we should be doing this as a community.
And Eric?
Yeah, I think Ellen nails it here, particularly in the area of like, okay, what are the requirements? Because there's sort of two factors here. I think the first part of your question is who's attacking us, and the second part is what are we doing about it? And Ellen just nailed the what are we doing about it. It is a bit regional right now, and it's also a bit vertical focused on what we're doing about it. You know, you look at NERC SIP, for example, and SIP 13. Very, very specific on the supply chain. So if you're not a power company, you say, oh, well, that's not my problem. Well, actually it is, because now we've got regulations emerging in Europe. Helen mentioned the Cyber Resiliency Act. I'd also point out the NIS2. They're basically saying, you know, you have if you're a critical producer, or even actually any software producer in Europe, if you're selling it, you North American producers selling software in Europe, you better comply with that or you're not selling anything. But we're seeing that all over the world. I'm seeing it in Singapore, new Singaporean regulations. I'm seeing it in the US. I'm seeing it in Japan. So from the regulatory point of view, it's a little fragmented right now, but I think it'll come together, and it's a little fragmented on verticals. You know, medical has different regulations, but basically they're all saying you need to know what's in your software. You need to know who you're dealing with. Now, who's attacking us is rather interesting. I'm not telling anybody anything you don't already know. We've got a very, very conflicted geopolitical situation going on around the world right now, whether it's the Middle East, whether it's Europe, whether it's Taiwan. And so we've got all these geopolitical hotspots, and software is just one tool in the attack toolbox. And so we're definitely seeing state threat actors using the supply chain to achieve their political or military objectives. But we're also seeing criminal groups starting to say, hey, you know, this is pretty darn good return on investment. And so if you're any large enterprise and you know, a good target for, say, ransomware, you're a good target for a supply chain attack, because that's just an easy way to mass distribute your ransomware. And we've seen that with a bunch of newer ransomware attacks in the last little while. Let's you know, don't bother trying to attack one company. Just distribute it out there and see what rolls on in, and then demand ransom. So I think pretty well everybody is going to get a bullseye on their back, whether you're a bullseye because you're a critical industry or a critical manufacturer in a key, basically critical nation state industry like power or manufacturing, or you're going to get a bullseye on your back because you're profitable and you can pay ransoms.
Yeah, definitely seeing that. Okay. So let's go to the next question. What are some of the biggest topics in terms of product security for IIoT products? And then do you see this strategy changing? Let's go Ellen first.
Yes. So I as you were talking, Eric, I was thinking a little bit about some of the things that we can do to ensure and prevent against malware. And so this, you know, we have this concept of signing code, which again is that's not new in general, but as a product security developer or someone who is creating these connected systems, it really is, I think, about securing that code that's running on the devices. And so you should be making sure that you know the origin of that code, the authenticity of the code, who wrote the code, and that you sign that code in a cryptographic way. And then as you are pushing these software updates out to, well, initially in the factory when you're flashing them into your product, that you do some validation that the hardware that you're putting it on, you know, it was your hardware and not counterfeit hardware and all that sort of thing. But I think it's all about identity and understanding the origin of the software, who's allowed to modify it, and how it's been modified. So the way that we do that, again, is by using signature verifications and just, you know, validating that it's really real and how it's been modified. So that's I think one thing that we're spending more time around, is how to do that from the start, and implementing the proper validation checks before you do an over-the-air update and install code. So that could be it's as simple as, you know, a single push of firmware, or it can be implemented in a manner like a secure boot manner, where you have a large system that's going to be booting up, and there's different stages, and you can verify every single stage before you put that code in. So I think that that's one thing that, from a design perspective, we're seeing more people take care about, to think through from a strategy standpoint. So I think that that's a really encouraging thing.
Yeah, I have to agree with you again. I think the whole question of provenance, like where the blazes did that code really come from? I mean, and that's sort of the basis of our company, is like a way for customers to be able to check and say, hey, yeah, I've got this blob of code. Is it valid? You know, did it really come from the manufacturer, and is it properly checked? And I think that's really, really important. People get lost in the whole question of vulnerabilities, which I think are really crucial. But if you're simply loading bad code onto your devices, or if you're loading code that has been made by really dodgy third parties, you know, you're going to be loading problems that you're not going to find in the National Vulnerability Database. And we've seen this, again, Dragonfly being a case in point. But, you know, a little while ago, we saw a company that was installing firmware updates into RTUs on pipelines in the Midwest. And, you know, little provenance checking that we did for them, we quickly pointed out that, hey, guys, you're loading a whole pile of Huawei software. Now, depending on your politics, that could be good or could be bad. But in the pipelines in the Midwest, loading Huawei cellular firmware is generally not considered a real good idea politically. It's fine in other regions. So I think you absolutely nailed it. And I do think you point out, like, code signing is phenomenal when you can get it. Unfortunately, on IIoT devices, it's rare, sadly, particularly in controllers. You know, just the amount of controllers out there that still don't have any sort of code validation or code signing mechanisms is unfortunately scary. And we're not going to tear those out. We're stuck with all that devices. So we need out-of-band ways to say, hey, this is the software I want to load into my plant floor. This is the update I want to do. Is it safe to install? Is it safe to use? Or even if you're a manufacturer of software, is it safe to even ship? You know, what is, you know, I've got a big company and I've got developers all over the world contributing to this. Are they contributing stuff I want my customers to use? And case in point, we uncovered for one of the large oil companies that one of their major suppliers was using very old, like absolutely ancient Linux kernels with the vulnerability list was a joke. I mean, it was a 2.26 Linux kernel in their code. And I mean, like, come off it, guys. So I think what you just mentioned there, Ellen, was spot on the money. We really want the provenance to, you know, we need that software provenance. Where the places did the software come from? Where did the components come from? And then what risks are they bringing into our systems? Without that, we're kind of guessing we're secure.
Right. And yeah, guessing is not a good idea. Now, I think we have Megan on the line. Megan, can you hear us?
I can. Hi, team. And I am so sorry that, number one, I was late to the call. And secondly, I'm having a bit of connection issues, but I'm having to write off my cell phone. But I promise I'll still give the audience everything I've got in responding to what I think was the question around what are good product security principles that customers should be looking for when they're purchasing products, and how does that relate to supply chain? Was that the question, Patrick?
You're right on. Yeah, go ahead.
Okay, so the good news that I have to tell you all is that all of the major industrials, often referred to as the Seven Sisters, it's Schneider, it's Rockwell, it's Siemens, it's GE, it's Emerson, it's Johnson Controls, it's Honeywell. We all follow a standard called IEC 62443. And there's two parts that, as an asset owner, you would want to look for when you're purchasing products. You would want to look for a certified secure development lifecycle, which is a 4-1 certification, and the maturity levels there ranging all the way from maturity level 1 all the way up to maturity level 4, which is the highest. And secondly, you would want to be looking for what are called 4-2 certificates, which are actually against the product. that speak not only to the way that the life cycle of the product is managed with the secure testing, with the SBOMs, with all the things that Eric and Ellen brought up in terms of how do you ensure that you're securely building and testing the product, but as well as the security features like the signed and encrypted firmware that Eric alluded to. Those would be found and would be present within that 4-2 certification. But I agree with the points that were brought up earlier. I would also add that manual code reviews, it was done very commonly in the past. Now there's a lot of automation with those tooling. The automation is great. But when you're looking at the security of source code repositories and you're checking branches of code into main, those manual code reviews can also be very helpful in ensuring that no one developer was capable of sneaking something into the code that otherwise should be there, that the customer is purchasing exactly what they intended to, nothing more and nothing less.
Fantastic. That's great info. And just I want a follow-up question. So when we're looking at attacks in these industrial environments, attacks on these products, what does that look like? And we'll start with you, Eric.
So the attacks that we're starting to see, I mean, there's been always the traditional attacks of, lousy validation of passwords and, people just being messy. Those still exist, bad account management, stuff like that. And people, what we saw, for example, in the Colonial Pipeline situation. But what we're seeing is much more of a sophisticated move now towards either finding vulnerabilities in code that are sort of latent, that are kicking around there, that people don't know the code is in their devices. So they don't even know to patch it. Log4j being a case in point, the whole pipe dream attacks being another case in point, but people just simply don't know the code's there. So if you're an attacker and you can find a vulnerability in some code, it can have a lifetime far past when it was a 0-day, because people just don't know to patch it. And then the second thing is, of course, is to inject bad code. And that was what we saw a little while ago, which fortunately got caught. But the whole XZ attack, where some nation state, I won't hazard a guess who, but some nation state was working very hard to poison a key open source repository that's used in the SSH secure shell, which is widely used in devices. So that, we're seeing those two forms of attack that are really about laying the groundwork for later attacks. When you're grabbing accounts, if you're attacking firewalls, all the stuff that we used to be seeing, it was sort of for immediate use, maybe, a couple of days, a couple of weeks. What we're seeing now is much more of this. Let's get a beachhead in there and sit on it, and we'll use it when it's appropriate for us to use it. Particular financial situation or a particular geopolitical situation. Well, we've got a beachhead. We know there's a vulnerability embedded in this controller, or we know that, and the customers don't know and they're not patching it. So let's take advantage of it. So I think that's where we're seeing the switch. We're seeing a lot more of what people would call an advanced persistent threat. And the key word there being persistent, like we get in there as an attacker and sit and wait. Have your beachhead established, and that's really where I'm seeing happening right now.
Fantastic.
Yeah, I could add to that, Patrick, if that's okay. I
Please do.
completely agree, and I would say another branch from that thought could be the whole collect data now, store it, and then assuming it's decrypted, but encrypted, take that data and then save it for a point later in time when I'm going to be able to unencrypt it and then use it for a purpose of ransomware or for something like that, which is in our world. We tie that into the whole post-quantum conversation, because when post-quantum computing comes, if it can break what we've encrypted today, and do it very quickly, then people who maybe have had access to our data or our systems are going to be able to instantly get in, even if it is encrypted. So that's just like a whole nother layer on top of what you were mentioning with vulnerabilities and just current state of things. It's the really, even if you do have some wrappers and you've encrypted things, think about just maybe some additional ways to protect that, because someone eventually with different technology could decrypt that data. So it really is a long-term strategy. It's not just an instant fix. And then being able to have a flexible way of thinking around that in the future as the landscape changes.
Okay, and Megan, did you have anything to add?
I do actually, and I'll be a bit contrarian, because I do always read the Dragos and the Mandiant reports that come out every year, and I believe that the data shows that most observable attacks in OT environments do not have to exploit any vulnerabilities at all. I think it was upwards of 70%. There was no active exploitation of a vulnerability involved for entry into the OT environment. What we're really seeing is products inadvertently directly connected to the internet. And so you can have an HMI or an engineering workstation, or basically any product that is capable of routing directly to the internet. That's how the bad guys are getting in. And yes, APT should always be a concern, and people should always be putting focus behind that, because unfortunately, none of us get to pick whether or not we're the victim of an APT. But I will say, with a dedicated APT attack, I don't know that any asset owner is going to be able to withstand or hold off a dedicated APT that is just continually targeting them and has an action or an objective that they want to execute against in that environment. So I'm not saying don't worry about APTs. You absolutely should. But what I am saying is that kind of everyday stuff that we see a lot is customers not knowing that they have product directly connected. And it's that direct exposure that is really kind of the beachhead, as Eric used earlier, or the front door into these OT environments. And from there, due to poor network segmentation or 1,000 different issues, they're able to land on different products and get visibility into other assets on that network. And they're able to move around however they want to, and either extract information, as Ellen mentioned earlier, for some other purpose at a later date, or the worst case scenario where they're actually looking to demonstrate kinetic harm.
Yeah, no, great points. Okay, and next question. How can I ensure the products we are using are free from technology provided by high-risk suppliers or adversarial state actors or criminals or others like that who would intend to do harm? And Eric, I'm going to start with you.
So that's where the whole question of the software bill of materials comes in. As Ellen mentioned earlier, we're seeing these regulations that are saying if you sell software, NIS2, for example, or the regulations in the US, if you sell software, you're going to supply a software bill of materials. For any of you who are not familiar out there with the software bill of materials, think of it as an ingredients list for software. You go buy a can of soup and you can look on the side of the can of soup, say it's tomato soup. And you hope the first thing you see is tomatoes and maybe a little water, and then a whole bunch of other ingredients. And that's exactly what a software bill of materials is. It's an ingredients list. So now that these are starting to become available and being regulated, and companies like Megan's company has been a great example. They're really at the forefront of being able to provide that information to their customers. It's really up to the customers now to read the label. In other words, to be able to analyze that software bill of materials and make sense of it and say, hey, these are the ingredients. What are the risks? And again, go back to my soup analogy. You can have all the labels you want. If you don't read the label, it's not going to help you any. So now it's really up to the end users to be able to be able to make use of those software bill of materials to say, hey, these are third parties that we're inadvertently getting. Are they risky to us? Are they potentially adversaries? Do we want them in our systems? And these are the vulnerabilities that come along. And these are the risks we're getting. And for companies, and there are still, unfortunately, lots of companies that aren't providing software bill of materials. There's lots of technology out there that will generate software bill of materials. So it's not just a black box anymore. Those IIoT devices, those controllers, those are now you can get a pretty good view into what the blazes you actually bought. What are the ingredients in your soup?
Yeah. And Megan, did you have anything to add there?
I was just actually going to give a thank you for the shout out, Eric, and I wanted to give a shout out to Cassie Crossley, who is our Vice President of Secure Supply Chain Security. She really has been a forefront leader in this space. She was a strong advocate of SBOM. Schneider Electric is a tremendous advocate of providing SBOMs. We work with companies like Eric's and others to provide this information to our customers and other people that want it. So that was the only thing that I was going to say, was just a plug-in for Cassie Crossley. And she does have a book out on this topic. If you haven't read it, definitely check it out. But that's all I had to add that Eric had not already said on SBOMs. And you should look for all other vendors being able to provide those to you as well. Now, on the customer end, being able to digest the SBOMs and then correlate that within your asset inventories, I think that is the next kind of big phase 2 of, okay, we've collected the SBOMs, they're out there. Now, how do people actually take action on them and use them within their environments? And I think it's a very exciting challenge before us.
Yeah. Yeah.
Fantastic. Ellen, did you have anything to add on this one?
Yeah, I would say to add and agree with all the previous points. It's also about understanding, I think Megan mentioned this, what is on the network. So being able to scan and understand what are these potential rogue devices that someone had put on the network, because it probably did help with remote access to a machine, or give some sort of status about the health of how something's operating, or collect data, or just make something more efficient. So that's why we do implement some of these technologies. But then thinking about that every time that you have something connected to your network, that can be the weakest link into your whole network if it's not secured properly. So I think being able to scan and detect and categorize, and then from a secure access standpoint, is how do you allow or create a secure connection between that device and wherever the data that it's collecting is going to. So typically that's going to some back-end system, or it's going somewhere else to be analyzed. And so we work a lot with companies that try to create these secure TLS basically connections between two different things, because you might be running over a network that could be untrusted, or it could be going over cellular or 5G or something like that. So we have to think about how this data is being transported, and then securing basically that connection over which it's traveling. So I don't want to go too much deep into that, but I think that's another way that we can think about setting up a secure framework here.
Yeah, I'd like to add something. I mean, Ellen makes a very good point about understanding what's on your network. And one of the things that I think has unfortunately happened over the years is oh yeah, we've got an HMI there. And that's not enough information, like what is actually running on that HMI? What other software is kicking around there? We're doing a lot of work right now in the manufacturing, the food and beverage industry right now, where we're analyzing the backups coming off of HMIs to build effectively a software bill of materials to find out, yeah, sure, it's got, Wonderware or whatever the HMI software on there, but there's a lot of other surprises in there. And not knowing that really leaves you vulnerable. So I think it's really taking that core asset inventory, that, what's hanging off the network, and expanding it to be more general and saying, what is really running on the network? What are the software packages? What are the firmware packages? What are the devices? Really expanding that out, because that's where we've got to go. There's starting to be some really great tools for doing that now.
Yeah, Eric, and even at the system level, things that have just been drag and dropped on, like putty and other things. Yeah, exactly. Which just had its own issue recently. Yeah. Okay. Okay. Out of the next question, our facilities include a disparate combination of technologies, from PLCs, VFDs, IEDs, FEPs, all the way out there, and IP cameras, things to laptops and off-the-shelf IoT devices. It's a mix. How can someone develop a cybersecurity strategy that covers all of this? This is a vast array of technology. I'm going to start with you, Megan.
Well, the audience can probably guess this because I'm a IEC 62443 gal, but I would say that 62443 definitely still applies to IoT and IIoT, even though the standard was originally written, I think, close to 20 years ago, more for the process automation space. But the good thing about 62443 is it's going to cover the products that asset owners are consuming in 4-1. It's going to cover the individual security of the products in 4-2. And then 3-3 is really cool in that it covers this entire system level that you're talking about, where no customer environment is homogeneous. You're never going to go into an environment and see just Schneider or just Siemens or just GE. All of our equipment live and play together and operate in customer environments. And so you really need an overarching framework like 62443 that can prescribe to you the healthy way that these products should be connected, how they should be securely deployed, and how they should be securely operated throughout their entire life cycle, all the way through to disposal of the products where you're getting an upgrade. 62443 is also helpful because it's an international standard. It's not just an American standard or a European standard or anything like that. It's something that all of your manufacturers are probably going to have access to. And if you're a multinational company, which many larger companies are, they operate in locations throughout the world, you can use this framework to kind of not only unite your technology, but also the people and the processes behind it. And the final thing I'll add is that I have seen language out there where folks will say that they technically comply to 62443. I love that they're supporting the standard, but what we really want to push the industry as what we want to hold ourselves accountable to as manufacturers, as system integrators, often left out of the conversation, by the way, as well as asset owners, is that we're actually certifying to it. So we have someone like a Patrick Miller coming in, doing a third-party independent analysis saying, this was correct, this was not quite correct, and this is what needs to be fixed.
Fantastic. Thank you. Thank you. I agree. Ellen, anything to add?
I think Megan covered it really well. Yeah, I would just add on, so 62443 again is a great framework that focuses in on trying to safeguard all this infrastructure. I think it is a combined responsibility of not only the component manufacturers and the control system manufacturers and that sort of thing, plus the machine builders or system integrators, as she called them, plus the operators, like who's running the plant, who's running the facilities. And so within that, there needs to be collaboration and cooperation around all of this functionality, the requirements, the guidelines, and then how it's actually implemented in order to have a secure life cycle for all this industrial equipment. So I've seen, in the IT space, we follow ISO 27000 series when it comes to frameworks around within IT, and again 62443 is the basis for what we're doing in the OT and production networks and machine to network communication. So I feel like every as we go on and as this is built out more and more into reality, I do feel like it's the way to go, and we're seeing solid security by design and lifecycle management of these critical components by using this framework.
Yeah, Eric?
Yeah, in a strange way, I actually think, well, first of all, I'm going to say that the whole question of IoT, IT, OT, IIoT convergence is a done deal. That horse has left the barn. There is so much mixture of IT, OT, IIoT gear on any plant floor today and there's so much interconnection. There's no way we have these isolated OT networks or isolated IIoT networks anymore. That's
you don't believe in the air gap?
I don't believe in the air gap. Well, maybe I believe in it, and I believe in unicorns too. But
Bigfoot, aliens, air gaps. Yep.
Yeah, exactly, exactly. So, but in some respects, I think it's getting easier because of that convergence. It isn't just on our plant floors, it's in the software we're using, it's in the firmware. You know, when software, I don't care what it's running on, it still follows the same principles. You know, we still see it's, you know, whether it's embedded Linux running on a PLC or in a camera, or whether it's a modified RTOS, which still probably Linux POSIX based, or it's Windows on your desktop, it's still following the same formats. And so, for example, in our company, we analyze software. I think we do 350, 400 different types of file formats and operating systems now. But basically, it's just the same. And so I think for customers, I think it's a bit of a mistake to segregate it out too much and say, oh, well, yeah, here's our process for IoT, and here's our process for OT, and here's our process for IT. I think it's really critical to say, hey, what are we bringing onto the plant floor, particularly during procurement? Saying, you know, what is this stuff, or into the factory or into the office system? I don't care where it's coming in. You know, really having those processes that Megan just, and follow those standards that Megan just mentioned, to say, what is it we're doing to make that blob of bits secure, no matter what device it's running on? And I think that's the really critical part. It really has to be universal today. And we're seeing that in the regulations too. The regulations don't say this is for OT. They say this is for software.
Yeah, that's my world. I live in the regulatory space too much. There's some, but it's getting to more. I think even regulation has recognized that what was OT, what was IT, what was IoT, XOT, IIoT, it's all just T. It's technology. In some cases, we see IT platforms used with an OT purpose, and it's getting to where a lot of it is just. And honestly, going forward in the future, it's going to get even muddier, right? It's just going to get more and more confusing. So back to Megan's point, picking something, because you manage what you measure. So picking something to measure that is a flexible framework that can embrace all of the forms of T, then you end up with something that's actually usable going forward. Yeah, agreed. Even in the regulatory aspect. Yeah. Fantastic. Okay, let's go to the next question. Checking our time. All right. So speaking of regulation and legislation, what regulation or legislation is helping or hindering securing IIoT for manufacturing? For example, we have talked about the US and the UK have passed consumer IoT regulation. And then, of course, the CRA in Europe is looking at having some direct impact. We've seen some statements in the US in addition around supply chain, not just in the consumer side, but supply chain for the critical infrastructure components. We've even talked about it in the US around communications gear. So what are you seeing that's helping or even in some cases hindering the IIoT space? Let's start with you, Ellen.
So I think we've already talked about IEC 62443 as the framework. And I think what really drives people to action is when that becomes a regulation and you can't release your product or you can't operate without meeting some of these requirements that come up in like the CRA or NIS2 directive or the machinery directive in Europe. So I think all of those are we've kind of covered a bit. Maybe one thing different that we're working on at Keyfactor is, and this is more of a just sort of a protocol, but the OPCUA basically framework to be able to have secure and reliable communication and exchange of data across different systems and platforms. Like we were mentioning earlier, it's not just one vendor. There's a variety of different suppliers of pieces that need to come together for a smart factory or a smart operation. So I think we're being we're sort of collaborating with that group to incorporate certificates and public key infrastructure and ways of doing authentication and identity, because we see a need to have sort of an open platform and sort of collaboration around that. So that's, again, that's not so much a regulation, but just I wanted to add that to the conversation as something additional that is a sort of a body that's influencing in this space.
Yeah, fantastic. Yeah, and it touches on the differences between regulation and standards. Okay, and then Megan, how about you?
Sure. I have to give the Europeans credit for the EU CRA, because this is a comprehensive, mega-loaded, very detailed regulation that's coming out that will ensure that if you are a manufacturer supplying product into Europe, you will need to meet this regulation by, I believe, January 2027. The goalpost keeps shifting a little bit there because they have to harmonize the standards. Again, giving the Europeans credit, I think anyone that has worked in this space can tell you the foundational basics of what we would hope to see present in any product that ships anywhere. What they're doing, though, is they are doing the difficult job of alignment to ensure that they have a good regulation that's actually enforceable, that the governing bodies over there can ensure that products are being built to this standard, either through self-attestation, where you prove that you did all of these things to build and secure your product prior to shipping in Europe, or in some cases, with I believe their class 1 product here, you're actually going to be required to have third-party certification. So when I think of any regulation, anything that has come out within the past 10 years that's really going to drive and impact product security, it's going to be the EU CRA. And what's going to be super interesting on top of that is that, again, I go back to the global multinational manufacturer angle here. The product that we're making for England or France or Sweden is likely the exact same product that we're going to be shipping into the United States. So the United States government and all of our critical infrastructures and asset owners are going to benefit tremendously from the work that the Europeans have done in the space with the EU CRA. And it addresses not only security features that should be present in products, things like event logging, the signed firmware, secure boot, things like that. It's also going to address the kind of the bread and butter that we all love talking about, like vulnerability and lifecycle management, end of life, end of support, how are customers made aware, how are they able to properly manage this risk. So kudos to the Europeans. I think the Americans and everyone else in the world is going to benefit from this. And we're also seeing a ton of good information come out as well from U.S. Department of Energy with cyber-informed engineering. Again, very, very similar premises, right? But the U.S. has not yet said that they're all in on regulation. From an American standpoint and being an American, I'm not always for regulation, I'll be honest with you. But I think in this space, the Europeans were really looking to get things done pretty quickly. They kind of said enough is enough, and they're moving forward, but we're going to benefit from it. So that's my take on the regulation side.
Yeah, well said. Eric, anything to add?
No, I think Megan nailed it there. What the EU has done with the CRA is impressive and amazing. It's going to impact the whole world. And if anybody out there is a manufacturer of IIoT devices and you haven't read that document, for God's sake, read it, because it's going to, if you want to sell in Europe, you're going to have to comply. Even if you don't want to sell in Europe, you're going to have to comply because all your competitors are going to comply, and it's going to be a competitive landscape. And even if you just sell in North America. So for God's sakes, if you're out there, read it or take a course on it or go listen. And if you're an end user, you want to read it or get the short notes on it, because there's so much in there that's going to help you. And you don't want to leave that stuff lying around. It's a career limiting move if you say, oh, well, yeah, we could have prevented that attack if we bothered to, use the S-bomb or, take advantage of, but I didn't have time, so I didn't get around to it. That's not a good answer. When that data is there, when the regulations are demanding that the suppliers give you information that will help protect your operations, you better use it. So I think that more than anything else is worth following right now.
Yep, agreed. And I'd like the point that Megan raised is the rising tide does lift all boats in this case. So if it's being done in Europe, it's going to be basically transitive across the entire planet as a result. So we see some of the similar stuff in the US where, like, if California does it, then the rest of the country has to do it. Now, in this case, we're seeing Europe. And I've had conversations about, how the US used to lead when it came to regulation and cybersecurity, in particular for critical operations. And now Europe is just gone far beyond and done so much more. So it's quite interesting. I was on the floor of another event recently, and I heard two different IoT manufacturers in two different presentations say they weren't worried about CRA and they weren't worried about NIS2. And I thought, you're a dinosaur. You will not be on the floor in the next couple of years. Yeah, I was absolutely floored when I saw that or heard that.
Yeah,
Okay.
that's opposite. I was at Embedded World a month or so ago, and everybody was talking about it. Yeah, it was
I was
definitely.
floored.
We
I
have
was
to
so
pay
surprised
attention.
to hear that. Yeah, I couldn't believe it. I was just like, wow, you're out of business. Right. As soon as those words left your mouth, you're out of business. Okay. Okay. So the next question. Okay, we've got about 10 minutes. Given your distinct vantage points, what emerging risks or vulnerabilities do you believe are being overlooked? And how can manufacturers proactively address them? Megan, I'm going to start with you.
Sure, and I hate to beat a dead horse here, but we're just seeing a lot of it across industry with devices directly connected to the internet. And in some cases, you know, I know the U.S. government did the 100-day sprint to censor all the electric utilities, and that was a worthwhile effort. It very much was. I truly believe that in the United States, we need like a 100-day push to find and get all the devices off of the internet, because that is just inherent attack surface. That is how these folks are getting in, and they're not necessarily APTs. They're you know, script kiddies and other folks like that, but that's how the ransomware is getting in, folks. So if I gave the audience one piece of advice, it would be have an asset inventory, keep it up to date as much as possible. I don't know that anyone can ever say that they have a 100% always accurate, up-to-date asset inventory, but striving for it should certainly be a goal. And then ensuring that you have proper network segmentation and that no devices are directly exposed to the internet. That's going to limit a ton of your attack surface right there. And I think if we did a push like that in the United States, it would reduce a measurable amount of immediate attack surface across all critical infrastructure sectors.
Agreed. Okay, and Ellen, your thoughts?
Yeah, I agree with all of that. I think it's about discovery and understanding what is in the network, in the environment, and then being able to categorize and be able to control and manage those. And like I was mentioning previously, if there is a need to collect data from that endpoint, to have a secure communication and only have authorized other devices or other systems be able to connect into that. So that's a way to really be able to establish a secure connection, and then make sure that the data that you can trust the data, that no one else is accessing it. So that's more like a secondary thing, but that's it. Like Megan was saying, understand, discover, control, manage, and then make sure you are, you know, only allowing certain people, authorized people or authorized systems, to access those devices. So it's a staged approach.
Yeah. And Eric?
Yeah, I'm going to just echo what Megan said. If you don't know what's on your network, if you don't know what's talking on the internet, you know, you're dead in the water. And that's unfortunately a sad situation. You can't defend what you don't even know you've got on there, or as Ellen says, you don't know what it's talking to. So I think it's really, really critical that we identify what's talking on the internet and what's talking on our plant floors and what's there, and then B, characterize it. Characterize it before you buy it, or characterize it once it's out there. But you know, understand that, you know, the words it's an HMI is not good enough. Or it's a PLC. You got to really know what's on it. What's it doing? It's all about asset management.
It is, and I am seeing a rise in like living off the land issues as well. And much to Megan's point, like the biggest issue we have is stuff connected to the internet. And there should be some concerted effort between whether it's ISACs or CERTs or government elements throughout all of the civilized world, for that matter, that there should be some push to get these things off the internet. Most of these companies don't know it. They should, but they don't. Many of them are too small, or they're just too big and too complex. There's lots of reasons. I won't say valid reasons, but there's lots of reasons. But the next stage beyond what's connected to the internet is when they do get inside, right, and they've abused some sort of authentication or something else. then they're doing a lot of what is, living off the land techniques, and it looks like normal traffic, and it's extremely difficult to detect, especially the really good ones. The noisy ones that come in, through the door with like a marching band, you're going to pick up even with, mediocre technology. But the ones we're really concerned about, it's a lot more difficult to detect. So those are some of the ones I'm seeing that are a little bit overlooked. Is some of that visibility once they get through, what's not already connected to the internet. Yeah. And of course, asset management, as Eric mentioned, that is so key. You don't know, if you don't know what you have, you can't defend it, period. Yeah. Okay. And with 5 minutes left, I'm going to jump over to our questions in the Q&A. Okay. And we've got one from James. Why should an end user trust the label? How should it be validated as product goes through its life cycle? And what mechanisms are used to prove it hasn't been tampered with? For example, SolarWinds has procedures in place to prevent tampering, yet code was inserted upstream. And Ellen, I'll start with you.
Yes. So I don't know. I think it really, you have to understand, and there is some level of trust to when you're purchasing a product. Again, in this case, something that you're putting into your network and your system should come from you should understand the company and who has written the code and where is the product. But then you also really are relying on them and the underlying software that they put in, the underlying hardware and chipsets and all the stuff that comes together. So it really does come down to you have to be able to trust them. But that is why we have these assessments and these certifications and then other independent bodies sort of helping to provide those checks and balances. But from a technology standpoint, it was what I was mentioning in terms of code signing and code verification and just making sure that from a factory standpoint, if you're using, in my world, keys and certificates and having that be the way to authenticate new device, that that from manufacturing from the start that you are injecting something as an identity that where it's come from. So it's all about the root of trust and the initial establishing that trust. So it just comes down to policies that are really implemented by the producer of these products as well.
Yeah. And Eric?
I think that the important thing here is that we've developed these relationships with our suppliers. I mean, we don't demand that we validate material data safety sheets or something like that. The important thing is asking, do you have this information available? And I mean, that's the sad part, is often the companies don't. So even we've made progress when a company can produce a software bill of materials, because it means they're looking at their code. They're aware of what they're putting in there. I recently was looking at some software, and we found, I think, 17 different copies of OpenSSL in that software package. I mean, clearly they had a development problem. But, so I think it really is, a lot of it is just getting, it isn't just having the label there, but the fact that the label is on the side of can of soup is meant that our suppliers are putting in processes to give us controls. Now, we can also go down the third-party validation. Again, somebody like Patrick can do a great job of validating that if you want it. But we've made a lot of progress, even just having the information, demanding that it's available on request.
Fantastic. And Megan, we've got 1 minute left. You want to get one little thought in here real quick?
Sure. I mean, my gut would tell me, since I think they referenced SolarWinds, would be security of the actual build environment. That's kind of what went sideways there. And then manual code reviews. Again, the automated tooling to do static analysis and SBOM and all of that, that's great. And you absolutely need to use that, because you're going to need those tools to do anything at scale within your environment. But it also goes back to the people, where no one person should be allowed to commit code without another individual that's trusted having reviewed that code manually for a branch to go into a main. I'd also speak to, we've seen cases of supply chain issues popping up where everything was done correctly within the source code repositories, everything was done correctly within the build environment. The product went to a factory floor to be compiled and manufactured and shipped to the customer. And you can actually have cases where there's malware or ransomware on factory lines. So again, it ties back to the 3-3 with 62443. And then finally, the secure transit and shipping of that product. Does the manufacturer have anti-counterfeit labeling? Can you tell that this is not a counterfeit product coming from a third party? And in some very extreme cases, depending on the customer, do you have geotagging on those packages so that you can monitor where that product is along its way to the customer? And is it stopping at a port for a longer time than it should be? Just any extra telemetry around complete understanding of how the product was built, how it was manufactured on an assembly line, and then ultimately, how did that product arrive at the customer site?
Fantastic. Really, really good. Wrap it up there for us, Megan. I want to wrap it up. We got to get off to the next event. I want to make sure we're on time for our IIoT world. Thank you to Schneider, Keyfactor, and Adolis. Your support makes sure we have all this great content to share. Thanks everyone for attending today. And if you have any follow-on questions, please feel free to send them to IIoT World. We'll get as many of them as we can get in the future. Thanks, everyone.